Bam. Okay, so we're recording now. So what we want to talk about is we want to talk about graphing from an equation, right? And mostly we're talking about slope-intercept form, which you guys tend to recognize pretty well. Slope-intercept form is, does anyone remember what slope-intercept form is? Perfect, right? Y equals mx plus b. It is the easiest form to graph from. It's why we like it so much, because it gives us a point, which is our y-intercept, and then using the slope, we can find the next point. And to graph any line, all you need are 2 points, right? So I'm going to start with a couple that might not necessarily be slope-intercept form. Like if I had something like x equals 3. This is an equation, right? It has an equal sign and it has something on each side of that equal sign. And if I wanted to graph that, it'd be a little bit different. I don't have a y value. I'm just saying that x equals 3. And if I wanted to graph something like that, my graphs are going to be like kind of rough because I'm just hand doing them. I'm not going to bother with the ruler. That would just be where x is 3. For every single y, x is going to equal 3, right? When we think in terms of this, it has an undefined slope. When we have that straight vertical line, the slope is undefined. The other option that we have is say I had y equals 3. Well, in this case, oh, look, my line's getting a little bit better. In this case, where y is 3, we're going to have a horizontal line that goes through it. And this one you can kind of think of as the slope. Like when we're talking in terms of a ramp, like a ramp has a slope. It has either a steady incline or a steady decline, depending on whether you're starting at the top or the bottom, right? And that is the slope. But if the slope is like this, where it's straight across, kind of like a sidewalk, we'd say there is no slope. The slope of this line, because it has no tilt, is just 0. No, this one would be 0. Like, think of it in terms of we can definitely roll a wheelchair along this, right? But we definitely wouldn't want to roll a wheelchair down this, right? If that helps. So now we're going to get to the y equals mx plus b. But those were just 2 little exceptions that I wanted to make sure you knew how to graph if you came across those. So if I have, say, y equals 2/3 x plus 3, and I wanted to graph it, everything I need to graph this, I have just by looking at this equation when it's written in slope-intercept form. I could practically draw graphs in my sleep because I draw them so much. It's a little weird to do it on a computer now because like I can't see what I'm doing on the tablet. I have to look at the monitor while I do stuff on just this like black board that I can't see anything on. But so everything I need is right here. I'm going to change colors so you can see the difference between the graph and itself. This 3 right here is my y-intercept, right? That plus whatever we're adding to our x value or subtracting from our x value, that's our intercept. It is plus 3. So I know at y positive 3, I have a point. And now I can find my next point using the slope. My slope, my m, equals 2/3, which means that I can go up 2 and I can go over 3. Now, keep in mind when we're talking about a positive slope, we can also go negative over negative. Like if we need to take it in the other direction because we need to make room, I could also go down 2 and then -3, and it's going to have the same result. But sometimes you want to go the other direction just to make it fit on the graph. So my options are I could go up 2, 1, 2, and over 3. I'm just kind of guessing there. Or I could go down 2 and -3, right? Same result. Notice how they all fall into that same line because the slope never changes. It's always up 2 over 3, up 2 over 3. And I can do this forever. And then let's see if I can actually, no, I missed the dot entirely. I'll just make it bigger. And so that would be how you graph this line. Now I'm going to do another one because I want you to see it with a negative slope. So what if I have y equals 2x minus 2x minus 3? When I go to graph this one, man, that is not a very straight line. But it's okay. You guys get the gist, right? Like, it's probably not a very accurate graph. So here, I still have y equals mx plus b, and what I know is my y-intercept is -3. And I know my slope, my m, equals -2, which is like saying -2 over 1, right? Which means I can either go down to +1, or I can go up to -1. When you have a negative slope, one of them has to go, either the numerator or the denominator has to be negative, but not both on this at the same time, right? Because think about that. If I took them both negative, negative over a negative is a positive. What seems incredibly difficult, Lauren? The graphing? I don't know. So here we have a y-intercept. It's at -3, which means that right here, I'm going to have a point at -1, -2, -3. Yes, going straight down in a wheelchair would be very difficult. It'd be fast, though. So we have our point at -3, and we know our slope is -2, right? So I can either take it down 2 and +1, or I can take it up 1, 2, and -1. Notice that the slant on this one goes down from left to right. If you ever have a negative on your slope is going to go down. Notice above, we have a positive slope. It goes up from left to right. A negative slope goes down from left to right. So if you've got a negative there and you graph it and it's not going in the direction you think it's supposed to go in, you screwed something up in the slope when you were entering it. What do you mean? Well, yeah, you know it's got to go in the negative direction, right? So as long as there's a negative in front of that x, you know it's got to go in this direction. So if you mess up your slope, you'll know. Yeah. Well, any whole number as a fraction would be itself over 1. Because when we're doing slopes, we have to have a rise over run, right? And yeah, okay. That's all right. You got to ask the question. Always better to ask the question. What if I have something like y equals 1/2 x? What would my y-intercept be on this one? Excellent. It would be absolutely 0 because what are we adding to this? Nothing, right? 0 is nothing. So when we graphed this, sometimes I go fast and my graph turns out way better. So when I went to graph this one, my point would be down here at the origin, right? And then I would count my slope from there. It's 1 over 2. So I go 1 over 2, right? Then I can do the next one, 1 over 2, make a whole line of them. Like that was my best one, and I did it really fast. I wasn't even trying that hard. So that's all how it works in this. Remember, sometimes you're not going to be given slope intercept form. And last week you had an assignment where you were going from standard to slope intercept form. So if you got something like 2x plus 3y equals 6, just make it go into slope intercept form. Just translate it. Subtract your 2x from both sides, right? It's going to give me 3y equals minus 2x plus 6. Keep in mind, I need to know what y is, not what 3y is. So divide and divide, and we get y equals, well, minus 2 divided by 3 is just minus 2/3 x. 6 divided by 3 is just plus 2. And now we're in slope intercept form, and we can graph that, right? Because here's our y-intercept, and here is our slope. Now, I'm not going to do any more with this on here with you guys. But what I want to do is go over to Delta Math really quickly and show you how to graph these into Delta Math so that you know how to work the graphs in there before you get to the homework. First, there we go. So I have to stop presenting because I was presenting a window. And I'm going to open Delta Math over here and then go into it. I should stop recording. There's no reason for me to keep recording. Maybe I shouldn't have stopped recording. Maybe I should have recorded this too, but whatever.